The Antech Wide Range Segmented Gamma Scanner, or Wide Range SGS, is a comprehensive automated radioactive waste assay system for measuring waste in drums. It represents a significant extension to the measurement capabilities of the original SGS developed by Parker, Riley, and Martin at the Los Alamos National Laboratory and now widely used for radioactive waste assay. The automated wide-range SGS consists of input and output roller conveyors, a drum rotation platform mounted on slide rails, a detector shelf and lifting pillar for drum scanning, and a transmission source pillar. It incorporates several novel features: drum weight measurement, a variable aperture collimator, a transmission source safe, automated adjustment of the drum detector distance, an automated filter for detector dose rate reduction, drum barcode reading, and drum dose rate scanning using a Geiger-Müller detector. Finally, for appropriate lower density waste drums, the device can also operate in tomographic scanning mode. The drum loading process starts with the drum rotation platform positioned at the input conveyor. The rotation platform moves to couple with the input conveyor parasitic drive. The roller conveyor moves the waste drum onto the drum rotation platform. The rotation platform, carrying the drum, moves away from the conveyor and decouples from the conveyor parasitic drive. When the parasitic drive is disengaged, the rollers on the turntable are locked to stop further drum movement. The drum and drum rotation platform are moved by the slide mechanism to the measurement position. The drum is now aligned between the detector and the transmission source. The detector platform moves forward so that the detector is in the measurement position. The detector shelf is raised so that the barcode reader is in the correct position to read the barcode on the drum. As the drum is rotated, the barcode reader scans the barcode and records the barcode identification. The detector shelf is raised to the top of the drum for pre-scanning. Before the SGS measurement is started, the drum is pre-scanned using a Geiger-Müller dose rate probe. Scanning with this probe is used to determine the surface dose rate, typically in units of microsieverts, at fixed heights of the drum. The dose rate information is used by the measurement algorithms in the controlling software to determine key parameters for the measurement. For example, the segment height, the measurement time for each segment, the drum rotation speed, and the distance between the drum and the detector are all determined during this pre-scan. The dose rate information obtained during the pre-scan and the drum weight determined by the load cell in the drum rotation platform ensure that the correct measurement parameters are employed. If the drum has a high surface dose rate, then the system will deploy the filter and/or adjust the drum detector distance so that satisfactory counting statistics are achieved with an appropriate detector dead time. Following the pre-scan, the drum turntable repositions and realigns the drum so that the drum is in the same orientation as it was on the conveyor. The detector shelf is now repositioned and the transmission source is raised from the source safe so that the transmission source and the detector are aligned at the start of the transmission measurement. In the transmission measurement, gamma rays from the europium-152 transmission source pass through the drum where they are attenuated by the matrix materials before being counted in the detector. During the transmission measurement, the source and the detector move together from the bottom to the top of the drum in such a way as to produce a helical scan of the drum. The transmission source and detector now move to the straight-through position above the drum. A straight-through measurement is made of the unattenuated gamma-ray beam from the transmission source. The attenuation in each segment of the drum is determined by comparing the attenuated and the straight-through measurements made using the transmission source. Comprehensive analysis software is available to both display and analyze the measured gamma-ray spectra in order to determine the radioactivity content of a waste drum. In the displayed data analysis screen from the measurement of a typical waste drum, the transmission source spectrum for europium 152 is shown from drum segment number 4, as is the transmission ratio as a function of gamma ray energy for this segment. On the completion of the transmission measurement, the shielded transmission source is returned to the source safe at the base of the transmission pillar. The shielding is so effective that the wide-range SGS achieves very low minimum detectable activity, or MDA, during the emission measurement of the drum. Once the straight-through measurement is completed, the detector is repositioned at the top of the drum in order to start the emission measurement. When the detector is repositioned, the drum rotation recommences and the emission measurement proceeds as a helical scan of the drum from top to bottom. With the wide-range SGS located in a low background position, and with very effective transmission source shielding, the instrument achieves a very low minimum detectable activity. The display and analysis software shows the emission spectrum for segment number 4 and the gamma ray peak for cesium-137 at 661 keV. Based on a traceable calibration and using a pre-selected library of gamma ray data, the analysis software determines the quantity of each selected radionuclide present in each segment of the waste drum. The emission spectrum for segment number 5 shows the two gamma ray peaks for cobalt-60 at 1173 and 1332 keV. At the end of the measurement, the detector shelf is repositioned and the drum is moved to a position so that it can be loaded onto the output conveyor. Once the measurement is completed, the analysis software determines the radioactivity content for the drum as a whole, using both the transmission and emission data obtained for each segment. The displayed data analysis summary screen shows the transmission ratio for the 1408 keV gamma ray from the europium 152 transmission source for all segments in the drum. This data is used to provide the density correction for the emission data. It also shows the measured cesium-137 activity for each drum segment in relation to the minimum detectable activity. The detector dead time as a percentage for both transmission and emission measurements for each segment is also displayed. Once the emission measurement is completed and the detector has been repositioned, the drum is moved to the unload position adjacent to the output conveyor. Once the drum has been outloaded onto the output conveyor, the drum rotation platform is repositioned in front of the input conveyor to receive the next drum. The arrival of the next drum is the beginning of a new assay measurement sequence.